Ever wondered how the frame relay configuration process works in network engineering? Well, let's take a journey together into the world of network engineering and explore the intriguing topic of frame relay configuration. Frame relay configuration plays a pivotal role in the vast realm of network engineering. It's a high-performance wide-area network (WAN) protocol that operates at the physical and data link layers of the OSI reference model. In simpler terms, it's a method of sending information over a network in a fast and efficient manner. This system of communication, while a bit dated, is still used and valued for its ability to provide a fast and reliable connection, especially in environments where speed is of the essence. It's an integral part of the networking world, acting as a bridge that enables smooth communication between different devices. Intrigued? Stay tuned as we delve into this fascinating topic. So, what exactly is frame relay? Well, frame relay is a high-performance wide-area network protocol that operates at the physical and data link layers of the OSI reference model. It's like the highway of data transmission, allowing information to move swiftly and smoothly from one point to another. At its core, frame relay is a packet switching technology. It encapsulates data into frames before sending them across a network. Unlike other protocols, frame relay does not perform any error checking or correction. Instead, it relies on the endpoints to handle these tasks, which helps to speed up the transmission process. Frame relay networks are typically set up using a hub-and-spoke topology. This design allows for easy scalability and efficient use of bandwidth. The hub or central router is responsible for managing traffic between the spokes or remote routers. One of the key features of frame relay is its ability to support variable length frames. This flexibility allows it to handle a broad range of network applications. Frame relay can also support multiple virtual circuits, providing a secure and reliable path for data transmission. Another significant benefit of frame relay is its cost effectiveness. Because it uses shared networks, it can reduce the need for expensive dedicated lines. Plus, its high speed and efficient use of bandwidth can help businesses to manage their data transmission needs more effectively. But perhaps the most compelling advantage of frame relay is its simplicity. It's straightforward to set up and manage, making it a popular choice for businesses of all sizes. And while it may not offer the same level of control as some other protocols, its ease of use and reliability make it a strong contender in the world of data transmission. So, in a nutshell, frame relay is a robust and efficient protocol that can support a wide range of network applications. From its flexible frame length to its cost-effective operation, it's a tool that can deliver substantial benefits for businesses and network engineers alike. Now that we have a basic understanding of frame relay, let's examine how it's configured. Configuring frame relay may seem daunting, but it's actually a straightforward process when broken down into steps. So let's dive right into it. The first step in frame relay configuration is to define the physical interface. This involves specifying the interface on the router that will be used for the frame relay connection. It's crucial because it lays the groundwork for the rest of the configuration process. Next, we move on to the encapsulation method. Frame relay uses a protocol called Link Access Procedure for Frame Relay, or LAPF for short. We need to set the encapsulation to frame relay to enable the router to properly encapsulate the data packets for transmission. The third step involves configuring the frame relay interface type. The interface type can be either point-to-point or multi-point. A point-to-point interface type is used when a single virtual circuit is established between two routers. On the other hand, a multi-point interface type is used when multiple virtual circuits are established from a single router to multiple destinations. The choice between the two depends on the network topology and requirements. Once we've set the interface type, we then configure the frame relay map. This is a critical step as it maps the IP address to the corresponding data link connection identifier, or DLCI. The frame relay map enables the router to correctly route the data packets to their destination. The fifth step is to configure the frame relay inverse address resolution protocol, or IRP. This protocol is used for dynamic mapping of IP addresses to DLCIs. Although it's not mandatory, it's often used in large networks to simplify the configuration process. After configuring IARP, we move on to the Frame Relay Local Management Interface, or LMI. This protocol is used for communication between the frame relay switch and the router. It's important to set the LMI type correctly to ensure smooth communication. The final step in the frame relay configuration process is to verify the configuration. This is done by using various show commands, such as show frame relay PVC, show frame relay map, and show interfaces. These commands help us to confirm that the configuration has been done correctly and the frame relay network is functioning as expected. Each of these steps plays a pivotal role in the frame relay configuration process. They ensure that the data packets are correctly encapsulated, routed, and delivered to their destination. Understanding these steps and their importance will make the frame relay configuration process less daunting and more manageable. And there you have it, the steps to configuring frame relay. Scene script. Frame relay has many use cases and there are also alternatives to consider. Let's dive into this. Frame relay, a packet switching protocol, serves multiple use cases in network engineering. It's often deployed in wide area networks, UANs, where its ability to handle data, voice, and video makes it a versatile tool. Frame relay is particularly useful in environments that require high performance and low latency, such as financial institutions and telecommunications companies. Now imagine a scenario where multiple branch offices need to connect to a central office. Frame relay can facilitate this by creating virtual circuits that provide a direct link between the branches and the central office. This results in efficient data exchange and improved communication. But it's not all about frame relay. There are alternatives that might be a better fit for certain situations. Let's look at some of them. First, there's multi-protocol label switching, or MPLS. It's similar to frame relay but offers more flexibility. MPLS can direct data along predetermined routes, reducing latency and improving network performance. This is particularly useful for voice and video, where a delay can lead to a poor user experience. Then we have asynchronous transfer mode, or ATM. Like frame relay, ATM offers a reliable data transfer method for WANs. But instead of using variable-sized packets like frame relay, ATM breaks data into fixed-size cells. This makes ATM a good choice for high-speed applications that require consistent performance. And finally, there's the Internet Protocol Security, or IPsec. This protocol is often used when the focus is on security rather than performance. IPsec encrypts data before it's transmitted across the network, ensuring that it remains secure from end to end. So, which one should you choose? Well, it depends. If you need high performance and low latency, frame relay or MPLS might be the way to go. If consistent performance is a priority, consider ATM. And if security is your main concern, IPsec could be your best bet. Remember, the best choice depends on the specific needs of your network setup. Let's recap what we've learned about frame relay configuration. It's been quite a journey delving into the nitty-gritty of frame relay, hasn't it? We started from the basics, understanding what frame relay is. Remember, it's a packet switching protocol that uses a variable length packet to transmit data over a wide area network. It's a technology that has been around for a while, but it still has its uses in particular contexts. From there, we went on to explore how to configure frame relay. We understood that it involves setting up a virtual circuit between 2 points in the network. This process includes configuring the router interfaces and defining the frame relay map. We also remembered that it's crucial to verify our configuration using the right commands to ensure everything is working as expected. Next, we touched on various use cases of frame relay. Remember how it shines in situations where the network topology is complex and requires a lot of connections. We also discussed how it can be a cost-effective solution for businesses that need to connect multiple locations. Finally, we talked about the alternatives to frame relay. While frame relay has its advantages, it's not the only player in the game. We have other protocols like MPLS and ATM that offer similar functionalities, but might be better suited for different scenarios. It's all about choosing the best tool for the job, isn't it? Now, don't worry if all of this seems overwhelming. It's normal. The key is to keep practicing and revisiting these concepts. Remember, repetition is the mother of learning. The more you work with frame relay and similar technologies, the more comfortable you'll become. And that concludes our discussion on frame relay configuration. Thanks for watching, and remember to subscribe for more enlightening content on network engineering.